Scientists are forever working with either very, very large quantities or very small quantities. If you think of the weight of an atom of carbon, you think of, say, the distance. Let's just talk about the distance to Mars. Now, that'll vary, obviously, rotations in the orbit, but just say it is 55 million kilometres. It's closest to the Earth, and so rather than write large numbers with lots of zeros and all that sort of stuff, it's probably had to come up with a way of representing that in a more succinct form. So came up with the idea of scientific notation. Now, scientific notation is expressed as a single digit, a decimal place, and then another series of decimal places, so digits in decimal places, multiplied by 10 to some power. So we'll just call it n. So this n is a way of determining how far, either this way for large numbers or this way for small numbers, we have to move the decimal place. So if n is negative, we have small numbers, and if n is positive, we have very large numbers. So our 55 million, which will have 6 zeros, how could we write that in scientific notation? Well, it's got to be a single digit, and then there's only one digit after that, which will go on that side, times 10 to some power. Now, how do we work out how many powers? So if it was 5.5, how many decimal places do we have to go to get to there? So there's our 5.5, so it would be 1, 2, 3, 4, 5, 6, 7. So it'd be 5.5 times 10 to the power of 7. And that's scientific notation. It's exactly the same number as 55 million. Just a more succinct way of writing the actual number. So for very small numbers, if you had a number like 0.000003601 and you were asked to write that in scientific notation, when you scan through, we know because it is a small number that n is going to be negative. If we look up here where we wrote that initially, so we've got a small number, so we know n is negative. So we scan through until we get to the first digit, and it's a 3. We straight away put, there's only ever one digit on the left-hand side of the decimal in a scientific notation. So we've got 3 point. Now we write the other digits. And then we've got our, and it'll be times 10 to some power. Now it's going to be negative because this is a number that's less than 1, quite small number. So how many places have we got to move the decimal place? 1, 2, 3, 4, 5, 6. Well, there we go. It's another 7. So 10 to the minus 7. That's purely coincidental. Very, very small number. So those two numbers are exactly the same. This is quite a large number. So we need to be able to do multiplication and division and addition, subtraction, if you like, of scientific notation. If we had, well, let's go the 5.5 times 10 to the 4 times 3 times 10 to the 7. We can regroup these, regroup those two together and regroup those two together. So 3 times 5.5, calculate if you have to, 16.5 times 10. Now we've got like bases, so we add the indexes, so 10 to the power of 11. Now we know that if our answer is in to be true scientific form, that we can only have one number before the decimal place. So we've got to write 1.65. Now if we multiply by 10, we'll get to that number. Because multiplying by 10, you just move the decimal place one spot, so it'll go between the 6 and the 5, which gives us that number there. We've still got 10 to the power of 11. And don't forget 10 is 10 to the power of 1. And from our laws of indexes, we know that 10 to the 1 times 10 to the 11, you add them, so you'll get 10 to the 12. So it'll be 1.65 times 10 to the power of 12. So that's how we do multiplication. Division, we've got 5.181 times 10 to the power of 5 divided by 9.37 times 10 to the minus 7 equals. Now we can write division in fraction form, 5.181 times 10 to the power of 5 over 9.37 times 10 to the minus 7. We can work this out using our calculator, and we get 0.5529 when we divide that into that. And when we're when we're dividing, we subtract the indexes. And we're going to put the answer on the top. So it'll be 10 to the power of 5 minus negative 7. And 5 minus negative 7 is 10 to the power of 12. Now that's not correct yet, because we know that we've got to have a number before the decimal place. So that'll be 5.529 times 10 to the minus 1. 10 to the minus 1 means move the decimal place one spot. That way, times 10 to the power of 12. 5.529. We can combine these two together, and that'll be times 10 to the power of negative 1 plus 12 is 11. So multiplying and dividing scientific numbers, and talked about the meaning of what the scientific notation is all about. Always there is one digit before the decimal place, and then you can have any number of digits after the decimal place, like this one here. And this number up here, this power, is how many places you have to move the decimal place. If this is negative 7, means I've got to move that back this way 7 places to get there. If this is positive 7, I mean I've got to move the decimal place 7 places that way, and that will give us that number there.